Hi guys, here we have a demonstration with Mrs. Brand and Ms. Mattice, and we're going to demonstrate convection currents that move in the mantle.
Yeah, so remember we were going about the layers of the earth. We've got the inner core, the outer core, the mantle, and then the crust is on the outside. So we're really focusing on that third layer, the mantle, and how that moves in a thick plastic, liquid solid kind of way.
Yes, and there are three things that determine how these convection currents are going to flow. One of them is density.
The other one is gravity.
And the last one is temperature. Okay, so we're going to do that demonstration for you now. The first thing I'm going to put in this large beaker, now this is room temperature water, is we have a little container here and it's full of blue frozen food coloring water. Okay, so I'm going to place that in and observe what's happening.
So the blue was frozen, and if you look carefully, you're looking to see what happens to the blue food dyed water. And it might take a little bit because it was frozen. You can see it coming out a little bit. Might be too frozen. I'll try tipping it on its side, maybe?
Yeah, see if that works.
As always, science isn't perfect, and sometimes you have to try new things. Ooh, there we go.
Yeah.
Okay, watch carefully to see where that blue dye goes. Oh, that's actually really cool. So the blue dye, because it's cold, is more dense.
And it's causing it to sink to the bottom.
Right, we talked about those density layers. So something's more dense than water, and that blue cold dye is water, but it's cold, so it actually does make water more dense. You can see it spreading slowly across the bottom. So again, that's because it's more dense and cold. And we've got a little bit of gravity pulling it down too.
Okay.
So now we're gonna add a red hot water to the
Opposite side. I'll try standing it up first, and if that doesn't work,
we'll find out what happens next.
Do the same thing we did in blue.
Ooh, I like the bubble sound. All right, so we're gonna watch what happens with the red. And
is it reacting the same way the blue did?
It's definitely different. And if you watch really carefully, where's that red going? It is going up. Why is it going up, Miss Mattice?
Because it is less dense, so it's going to rise to the top.
So that water was heated.
Yes, and it's just like temperature in your home, air.
Hot air rises.
Yep.
So does hot water. So you can see the blue puddling across the bottom. It's kind of working its way over to the red, which is our hot. And watching, that's pretty cool. You can see that the red is now mixing with the blue, because the blue, as it gets heated, becomes less dense with temperature change.
No, yes, as you can see, I can actually see this from up above. You can see the blue starting to rise on this side because it's getting closer to the heated liquid.
And then the red is coming down and across. And eventually what's going to happen is it's going to just keep on cycling. It's going to get warm and rise. Then it comes over here, it gets cool and sinks with gravity and more density. And it just keeps on cycling around. And zoom in on that cool color. Anything else, Miss Mattice?
I don't know. We have our volcanoes. So
ooh, yes. Let's put that in there.
Sometimes we have magma that erupts. It's a volcano.
Underwater volcanoes.
Yeah. Okay. And that's
here we go.
Lava. Here we go.
Oh, nice. That's a good spot. It's causing everything to rise, and it's forming that beautiful color.
Ooh,
so volcanoes obviously are super hot. So they're going to change the temperature of the water greatly. So you can see it rising very quickly, changing the color at the top. with its lower density as it's heated. And then eventually, because that cycle just keeps on going, those convection currents just keep on going, it'll eventually turn the whole jar one color.
Yep.
Through mixtures. Mesmerizing. And that is all about convection currents.